Good morning to all of you. So today we are going to discuss with sign convention. Okay, sign convention for reflection by spherical mirrors. Sign convention for reflection by spherical mirrors. This sign convention we call it as new Cartesian sign convention. Okay, this is known as new Cartesian sign convention. What is the meaning of Cartesian? Cartesian coordinates, xy coordinates, we usually call it as Cartesian coordinate system. X axis, y axis, x dash axis and y dash axis. This is called Cartesian coordinate system. And you know the values that we are usually adopt toward right and left. Positive axis, this is a positive value. Y axis we take it as positive. X dash axis we take it as negative. Y dash axis we take it as negative. So in this new Cartesian sign convention for reflection by spherical mirrors, so almost same kind of pattern we adopt. For this, we'll see the Cartesian coordinate system. I am going to draw xy axis. So this is your xy axis. Now, in this case, the pole of the mirror will be always at the origin. This is origin. So I am taking a concave mirror here for my reference, and this is your concave mirror, and this is the polished side, and you can see that the pole of the mirror is at the origin. This is the pole. So pole is at the origin or coordinate system. So this is your x, this is your y, this is x dash and y dash axis. So in the new Cartesian coordinate system, so we have to place the mirror in such a way that the pole is at the origin. Or first point you have to take it as the pole of the mirror is taken as the origin. That's the first point. Pole of the mirror is taken as the origin. So P is taken as the origin. Next important point is object. First point, pole at the origin. Second point, object is always placed on left side. This is your object. Object is placed always on left side as per the sign convention. Okay. And the light ray will come from left side to right side and incident on mirror. So this is light rays traveling from left to right. That is the next point. So rays of light, they are coming from the object. It is from left to right. The incident on the mirror in this way, left to right. Yes. Next point, we have to see all the distances are to be measured from the pole. All the distances are to be measured from the pole. And those distances which are measured toward right side from the pole, that means toward right side, from the origin is taken as positive, and those distance we are measuring toward left side from the pole, they are taken as negative, and distances what we measure upward perpendicular to the principal axis. So this is the x axis will be taken as principal axis, the distance measured in the upward direction positive, and distance measured downward perpendicular principal axis in the downward, that we will take it as negative. So these are the different important points regarding new Cartesian sign convention. So what are the important points? I repeat. First point is pole of the mirror is taken as the origin. That is the point here, origin. Origin coordinate 0, 0. Next point will be object is always placed to the left side of the mirror. The object is here, marking here, left side. That means the light ray from the object, that is falls on the mirror from left hand side, left to right travel. Light is traveling from left to right. All the distances are to be measured from the pole. Next point, all the distance measured to the right of the origin toward right side along positive x-axis. You can see that positive x-axis, that is taken as positive, and all the distance measured towards left side, that along x dash axis, that is taken as negative. All the distances measured perpendicular to the principal axis upward, okay, that is taken as positive, that is along y axis. All the distances measured perpendicular to the principal axis downward, that is y dash axis, that are all taken as negative. These are the important points regarding the sign convention. Okay. So I repeat, this is a Cartesian coordinate system, means xy z system, xy system here, along x axis positive value, x dash negative value, y axis positive value, y dash we are getting negative value. And pole of the mirror is taken as the origin, that is the first point. Second, object should be always on left side. It is always on left side object. So you see that light ray travels from left to right and falls on the mirror. Next, you have to find all the distance are to be measured from the pole, and those distance measuring toward the right side from the origin, that is along positive x-axis, will be taken as positive, and those distance measuring towards left side, that is negative the x-axis, x dash axis, is taken as negative. Distance measured upward, that is along y-axis, positive, and distance measured downwards, that is along y dash axis, they are taken as negative. Okay. So as per sign convention, I am going to explain the different points in the case of concave and convex mirror. We will see. This is your concave mirror. Object is always on left side. Object is always on left side, and we will see real images. Real images are formed in front, A dash B dash. Virtual images are formed behind the mirror. In the case of convex, object is here always on left side, and it produces virtual image always on right side. So this is virtual image. This is virtual image. So with respect to image formation of concave and convex, we see these points. Object is always on left side, but if it is a real image, it is formed on left side. If it is a virtual image, it is formed on right side. And in the case of convex, object is always on left side. Virtual image, it forms always virtual image, so that is always formed on right side. So you recognize this point. And real images are always inverted image, that you can see as per the diagram here, inverted. Virtual images are erect. So this is erect image. So here two important points for sign convention. So this is the P. If you measure object distance, it is towards left side, that will be always negative. Here also from the pole, object distance are always negative. And if it is a real image, it's a real image. Real image will be in front of the mirror, so distance to the real image is negative. And if it is virtual image, we are measuring the distance toward right side. So that will be positive. So object distance always negative. Real image distance positive. Virtual real image distance negative. Real image distance negative. Virtual image distance positive. And here in the case of convex mirror, object distance is always negative and virtual image is toward right side, that will be positive. This is some points regarding the sign convention. So as per sign convention, I am just explaining object distance and image distance. So you are well aware of real image and virtual image. So I repeat. So here you see object always on left side, whether it is a concave mirror or a convex mirror. So distance is measured toward left side from the pole, it is taken as negative. Next, about the image. If it is a real image, it is formed in front, so measured toward left side. So image distance is negative, that is for real image. Virtual image is formed behind, its distance is measured toward right side, so virtual image distance is taken as positive. The convex mirror, it forms always virtual image, okay, and that is behind the mirror right side, so it is taken as positive. U will be always negative. Some more points I will explain on the way when we discuss the mirror formula. So this is about the sign convention. Next point, what is mirror formula? Very, very important one. What is mirror formula? So for a mirror, we recognize U. U stands for object distance. Distance of the object from the pole of the mirror. That is called object distance. It is represented by letter U. V, it is image distance. That is the distance of the image from the pole of the mirror. Next is F, small f, is called focal length. What is focal length? It is the distance between pole and focus. PF equal to small f. You know this point, focal length. It is the distance between pole and principal focus of the mirror, that is known as focal length. U is the object distance, distance of the object from the pole, and V the image distance, it is the distance of the image from the pole, and F focal length, distance of the focus from the pole of the mirror. So mirror formula, it is a relation involving object distance U, image distance V, and focal length of a mirror. So mirror formula is the relation involving object distance, image distance, and focal length of a mirror, and it is given by 1 by U plus 1 by V is equal to 1 by F. Very important relation. All should write this equation 5 times in the copy. Mirror formula. What is mirror formula? It's a relation involving object distance U, image distance V, and focal length F of a mirror, and it is given by the equation 1 by U plus 1 by V is equal to 1 by F. And this equation is valid for all the kinds of mirrors. Okay, this is valid for concave and also for convex, whether it forms real image or virtual image, same equation is used. That means this is applicable in all situations for all the spherical mirrors and for all positions of the object. You keep the object anywhere, whether it forms real image, whether it forms virtual image, whether it is a concave mirror or whether it is a convex mirror, same equation is there, that is 1 by U plus 1 by V equal to 1 by F for all the mirrors and all types of image formations, and we have only one formula, that is 1 by U plus 1 by V equal to 1 by F. But the importance goes to this: whenever we substitute the values of U, V, and f in this equation, okay, when we substitute these values in the equation, we have to give sign. You have to give sign as per sign convention. So when you introduce numerical values in this equation, when you substitute numerical values in the equation, we have to follow the sign convention. With sign conventions, we have to put numerical values. That means object distance, if it is given, you have to substitute that value with sign as per sign convention. Okay, so I will give some more points regarding this. So this is your mirror formula. Last class we have seen magnification. I think all of you remember what is a magnification, linear magnification of the mirror. So this is the first equation you have to learn, and second equation is magnification. Linear magnification is given by linear magnification is given by m equal to a dash b dash divided by ab, size of the image upon size of the object is equal to minus v by u. This is another important equation. These two equations we have to remember, very important. In the case of mirror, first one is mirror formula, 1 by u plus 1 by v equal to 1 by f. Next one is linear magnification, that is size of the image upon size of the object. It is related to object and image distance as minus v upon u. U stands for object distance, v stands for image. Whenever you substitute the numerical value in any of these equations, we have to use the sign convention. Okay, I am just recalling sign conventions. Here you have u is there. What about u? And what about v? What about f? We have to give the signs for all the three letters. U, we have to give the sign. V, we have to give the sign. F, we have to give the sign. So what are the sign conventions for u, v and f? We will see. Concave mirror I am taking. If we are using concave mirror, first one, concave mirror. This is your concave mirror. Concave mirror can form real as well as virtual image. Object is always on left side, no doubt, and therefore its distance is to be measured from the pole to object toward left side. So u always negative. Okay, so u always negative. U always negative. U always negative because object is always on left side. Next we see what about v, that is image distance. Image distance means image can be real image or it can be virtual image. Image can be real or virtual. Okay, if it is a real image, where it will be? Real images are formed in front of the mirror. This is your real image, A dash B dash, a real image. So, image distance is measured from the pole, it is toward left side. So, for real image, V is negative. For real image, V is negative because it is in front of the mirror, distance you have to measure towards left. Okay, what you can say about the virtual image? Concave mirror can also form virtual image. Virtual image is here A dash B dash. So, we have to measure the distance from the pole to right side. So, this is positive measurement. This is negative measurement, this is negative measurement. So, for virtual image, then V is taken as positive. As per the sign convention. And what about the height? AB, the height AB is measured vertically up. So, that is always taken as positive. And A dash B dash, image, A dash B dash, real image, it is measured downward. So, it is height is negative, and for virtual image, A dash B dash, that is you are measuring in the upward direction, that will be positive. So, AB measured upward, positive, Real image A dash B dash is downward, that will be real image height is measured as negative. Virtual image height is measured upward and that will be taken as positive. So this is about the height, that also we will see on the way. So this is about the concave mirror. Okay, what about the convex? Convex we will see. This is a convex mirror. Object is always on left side. So U always negative. Convex mirror forms only virtual image, erect and diminished. So it is on right side, A dash B dash. So object distance always negative and image distance is toward right side you measure, that will be positive. So for convex mirror, U always negative and V will be always positive because it forms only virtual image. So two terms we have seen, one is object distance U and second one image distance V. And one more point is there, what about focal length F? So that we will see focal length F. How will you find out focal length F? So third point regarding the focal length F. In the case of concave mirror, where will be the principal focus? Object is on left side. The principal focus will be here. It is a point on principal axis. It is on left side. So distance is measured from P to F is toward left side. It is taken as negative. So F is negative. If it is a concave mirror, you have concave mirror. So for you have focal length for concave. The concave and you have convex. Concave mirror distance is distant to the focus. We are measuring toward left side. So for concave, focal length is negative. Very important point. For convex, the principal focus is on right side. So distance from P to F we are measuring toward right side. So it is positive. For convex, the focal length is taken as positive. So you can see the sign convention about three terms U, V and small f in connection with mirror formula. Okay, and also for magnification. So U always negative. If it is V, real image it is negative and virtual image positive. Focal length concave negative and convex it is positive. You can see this diagram, do it in the copy. Okay, we go for a numerical and we'll recognize how we can use the signs along the numerical values in the two equations. One is mirror formula, another is equation for magnification. So first point, it is on example we are taking on NCERT, page 170. Example as 10.1. A convex mirror used as rear view mirror in the automobile has a radius of curvature 3 meter. So you are given a convex mirror. So first we write convex mirror. The radius of curvature is given to as R equal to 3. So plus 3 meter. And an object is located 5 meter from this mirror. Object distance is given as 5 meter. So object is located at 5 meter from the mirror. Find the position, nature and size of the image. The object is here. Any object you can take, that is AB in front. It is 5 meter in front of the mirror. So you have to find out the image. Where will be the image and nature of the image. So how will you write this? U equal to we have to put minus 5 meter. Why? Because object is always on left side. It is, we have to take it as negative sign. Radius of curvature is 3 meter. So focal length is R by 2. It is equal to 3 by 2. So F equal to plus 1.5 meter. Why we write positive sign? This is because it is convex. Convex mirror focal length is positive and radius of curvature also positive and object distance is negative. And what we want to find out? We have to find out where will be the image and what will be its magnification, about the size. So first we use mirror formula, 1 by u plus 1 by v is equal to 1 by f. So 1 by v is equal to 1 by f minus 1 by u. Substitute the values 1 upon f, f is positive, plus 1.5 minus 1 upon u. The value of u is minus 5. So you have to put the sign. You have to put the sign also here. So 1 upon v is equal to 1 upon 1.5. This minus minus become plus and it will be plus 1 upon 5. Now we will take the LCM. So that is 1 upon v is equal to 1.5 into 5. That is 7.5. This will be 5 plus 1.5. So 5 and 1.5 is 6.5 divided by 7.5. So this is 1 upon v is equal to 6.5 upon 7.5, which means that you have to take v. So reciprocal, take reciprocal. It is 7.5 divided by 6.5. So the value of v is equal to, it is equal to 1.15 meter. It is positive, positive sign. So positive means that it's a virtual image. It is measured toward right side from the pole. Okay, measure toward right side. So first part is completed. So value v is equal to plus 1.15 meter. It's a virtual image behind the mirror. Behind the mirror we are getting the image. That is why it is positive. Now we have to find out the size. For the size we will be using the equation magnification. So here on the top I will be using that. So magnification is given by the term m equal to minus v by u. That equation you have to use, magnification. M is equal to minus v by u. Magnification is given by m equal to minus v by u. Equal to minus, the value of v is plus 1.15 divided by, the value of u is minus 5. Minus minus cancel and this is equal to 1.15 divided by 5. So this value you are getting it as a positive value 0.23. So the magnification. So magnification positive, virtual image positive is a virtual image and diminished image. So this virtual, you can see again virtual. What about the size? This value is 0.23, which is less than 1. So we say that it's a diminished image. It is a diminished image. So virtual erect diminished image is formed and distance of image is 1.15 meter behind the mirror, and thus it is smaller in size. The image is smaller in size by a factor of 0.23. Okay, so we call it as a diminished image. So here we use the signs. Focal length is taken as positive, then we substituted, and image distance is or object distance is taken as minus u. So automatically you will get the sign of v. Sign of v is automatically appear in this value positive. If it is positive, it's on right side virtual. If we are getting v as negative, it will be a real image, it will be on left side. I think this point is clear to all of you. Okay, one more point. Again from NCERT, suppose this is a 1 mark question. Suppose you have given a convex mirror. You are given a convex mirror of radius of curvature is given as 32 centimeter. Find its focal length. Find its focal length. So 1 mark question, board question. F equal to r by 2. That is equal to 32 by 2. Focal length is positive. So you have to write plus 16 centimeter as per sign convention. Positive sign means that it is a convex mirror. When you write F plus 16 centimeter is a convex mirror. When you write f equal to minus 16 centimeter, it refers to a concave mirror. Okay, so these are the important points. So in the next class, we will see more examples. So you have to copy this example 10.1 and you have to practice. Also, you have to complete the diagrams for Cartesian sign convention, new sign convention for spherical mirrors. That diagram also you have to complete, and you have to complete the example 10.1 in the copy. So once you recognize the signs and how to substitute, you can do any kind of numericals. Okay, thank you. Other points will continue in the next class.